Hello everyone, I am Dr. VRAO. In the lecture 70, that is in the introduction of chemical kinetics, we came to know that chemical kinetics is a technique complementary for thermodynamics, complementary to thermodynamics for studying the reactions, and moreover chemical kinetics, that it is a branch of chemistry that deals with measurements of rates of chemical reactions under the conditions of temperature, pressure and concentration. Right? In this lecture, that is before we are going to learn various concepts in chemical kinetics, we should know rate and rate of reaction. Right? Before we are going to learn various concepts in chemical kinetics, we should know about rate and rate of chemical reaction, because all the concepts in chemical kinetics are in relation with the rate of reaction, right? So, what is rate and what is rate of reaction, right? Rate and rate of reaction. Right? By virtue of meaning of rate, rate is change with time. By virtue of its meaning, change with time. That is, rate, its meaning is change with time. Then what is rate of reaction? If we confines to the chemical reaction, for example, if we confines to chemical reaction, that is in chemical reaction, 1 minute, okay. What is rate of reaction? If we confines to the, or if we are studying the chemical reaction means in which reactants are converted into products, that is chemical reaction in which reactants are converted into products, right? Reactants converted into products. Then we can say rate for this chemical reaction, that is rate of reaction. So, rate is nothing but change with time. In nutshell, rate is nothing but a change with time. And rate of reaction, if we confines to a chemical reaction, or if we are studying a chemical reaction, that is chemical reaction means in which reactants are converted into products. So, for that reaction, we can say the rate of reaction, because there is a change with time, right? So, in chemical reaction, that is reactants are converted into products. Then what changes in this reaction with time? What changes in this reaction with time? The answer is concentration changes with time. That is concentration. We know the meaning of concentration, okay? Concentration changes with time, right? For example, if we confines to the change in terms of reactants, or if we express the change in concentration in terms of reactants, then the concentration of reactants goes on decreasing. Concentration of reactants goes on decreasing, and in the due course, reactants disappears. That is, all the concentration of reactants converted into, and all the concentration of reactants converted into products, right? So, rate of reaction in terms of reactants, in terms of reactants. Okay, already I told you this is a chemical reaction. What changes with this reaction? Concentration changes with the time. If we consider the change in concentration in terms of reactants, reactants concentration goes on decreasing. In due course, reactants disappears, right? For example, if we consider the concentration change in terms of products, in due course concentration of products increases, alright. So, if we consider the change in concentration in terms of reactants, reactants concentration decreases and in due course reactants disappear. That is, all the reactants are converted into products. That means reactants are disappeared. If we consider the change in concentration in terms of products, that is, in due course concentration of the products increases, right. Now, based on this analogy, we can assign a mathematical equation for rate of reaction, right. That is rate of reaction, rate of reaction. So, rate of reaction, when we consider the rate of reaction in terms of reactants, in terms of rate of reaction is nothing but decrease in concentration or change in concentration. When we consider the rate of reaction in terms of reactants, that is, what happens when we consider the concentration change with respect to reactants? Reactants concentration decrease. So, that is decrease in concentration, decrease in concentration of reactants. Okay, concentration is represented with square brackets by time taken, by time taken, time taken, right. Right, decrease in concentration of reactants by time taken. But this decrease in concentration is represented by represented with a negative sign, represented with a negative sign. So, that decrease or gradient we can represent with this delta by time taken, that is delta t, with the as when we consider the concentration change in terms of reactants, concentration decreases and that decrease is symbolically represented by that decrease is represented with a negative sign, right. And when we define the rate of reaction in terms of products, okay, in terms of products, what happens? Concentration of products increases, in due course concentration of products increases, right. So, what rate of reaction, right, is nothing but concentration change. What happens in the concentration of reactants? Increase in concentration of products, right. So, in terms of products, rate of reaction is defined as, or mathematically it is given by increase in concentration of products by time taken, by time taken, right. So, this increase, that is a gradient, okay, increase or decrease, or okay, that is represented by a delta, okay, and it is P, concentration change with delta T. So, here the concentration of products increases, that is why we assign a positive sign for this increase in concentration. Okay. When we define the rate of reaction in terms of reactants, or with respect to the concentration of reactants, we assign a negative sign because concentration of reactants decreases. Okay. When we say the rate of reaction with respect to products, we assign a positive sign, okay, that is a positive sign, because as the concentration of products increases. Okay. So, by this analogy or by this discussion, we came to know that during the course of reaction, what is course of reaction? In the during the progress of reaction or course of a reaction, reactants are converted into products. What changes in this reaction with time? Concentration changes with time, and that concentration change with time we call it as rate of reaction. We call it as rate of a reaction, right. So, during this progress of the reaction, concentration of the reactants goes on decreasing and concentration of products goes on increasing. That is, concentration here, the concentration of reactants goes on decreasing with time, and here the concentration of products increasing with time. So, concentration changes with time. Okay. In one case concentration decreases and in another case concentration increases. So, we can plot a graph. Between concentration versus time, because concentration, time, these two are interrelated. With increasing the time, concentration decreases, or with increasing the time, concentration increases. So, these are the two variables. One is independent variable and another one is dependent variable. So, we can draw a plot or we can draw a graph between concentration and time. So, let us draw the graph. Okay. So, these are the graphs, right. Here the concentration versus, we plot the graph between concentration versus time, that is concentration. Here the time is independent variable and concentration is dependent variable. A graph is always plotted between independent variable and dependent variable. Time, there is no change, time is independent, it does not depend on anything, but depends on time, concentration changes. That is why it is called a dependent variable. So, graph is always plotted between independent variable and dependent variable. Usually, we take the independent variable on x axis, right. So, when we plot the graph between concentration versus time in terms of for the concentration change of reactants, concentration of the reactants goes on decreasing, right. This is the time scale or the time axis. For example, this is the point, this is the time scale, okay. This is the point, say let us say this is the point time t1, where you want to know the concentration of reactant. Then you just draw a perpendicular onto this curve, you draw a perpendicular onto this curve, right. And if you want to know the concentration corresponds to the time t1, you just draw a perpendicular onto this y axis, right. So, where the concentration and the corresponding to time t1, the concentration of reactant is R1, right. This is right. And if you take the time t2, if you take this, if you say this is the time t2 and you want to know the concentration of reactant, okay, you just draw the perpendicular and you want to know the, if you want to know the concentration of reactant at this time, you just draw a perpendicular onto the y axis, that is time t2, corresponding to time t2, the concentration of reactant is R2. Okay. So, between this two time limits, between these two time intervals, concentration of the reactants decreases. Here the concentration decreases. Between these two intervals, concentration of the reactant decreases, right. The concentration decreases, right. So, that decrease, when we write the rate of reaction, right? That is here the concentration change is R2 minus R1 or R1 minus R2, or just it is a change R2 minus R1 or R1 minus R2 by delta T or T2 minus T1. Here the rate of reaction, we expressed the rate of reaction between the two different time interval, that is two different times, that is at two different intervals, that is, we express the rate in this time interval, right? Then this rate of reaction is called average rate. This rate of reaction is called average rate. Okay. So, this is the rate of reaction. Rate of reaction is nothing but concentration change with time. So, here the concentration changes with time. Okay, concentration changes with time. Between these two times, between this this interval, we express the rate of reaction. Okay, in this interval, when we express the rate of reaction between a particular time interval, that is called average rate. That is called average rate. This rate of reaction is called rate average rate, right? Average rate, right? So, here the rate is expressed between that is here the average, therefore, average rate depends on concentration change and time taken for that change. So, average rate, you simply you keep one point in your mind, average rate is average rate depends on concentration change and time taken for that change, right? Okay, time taken for that change. For example, if you want to know the rate at a particular instant, if you want to know the rate of that chemical reaction at a particular instant, then you draw a tangent on this curve, you draw a tangent on this curve, and measure the slope of this curve, that gives instantaneous rate, because we are measuring the rate of reaction at a particular instant. So, if you want to know the instantaneous rate, if you want to know the rate of reaction at a particular instant, then you draw a tangent on this curve and measure the slope of the curve, and that gives the instantaneous rate. That is slope. What is slope? It is nothing but dy by dx. It is nothing but dy by dx. That is, here the y on y axis we took concentration, on the x axis we take time. So, dy by dx, slope is nothing but dy by dx. That is infinitesimal change in y variable on y axis and infinitesimal change of variable on x axis. Okay, dy by dx. Here y is r and x is time. So, we can write d by dt of constant slope of this curve, that is reactants graph, concentration of reactants. Okay, so this is the slope. So, this slope gives the instantaneous rate. Okay, this is average rate. Average rate means the rate measured at two different the rate measured for between the two time intervals, that is at two times. That is, here the time t1, this is the time t2. Okay, time taken for this change in concentration is t2 minus t1, or r2 minus r1 or r1 minus r2. Okay, that gives the average. But instantaneous, what is the difference between average and instantaneous? Average rate depends on concentration change and time taken for that change. But instantaneous rate, if you want to measure the rate of reaction at a particular instant, then you just draw a tangent on this curve and measure the slope at that instant, measure the slope at that instant. That gives the instantaneous rate. That gives the instantaneous rate. This is average rate, and instantaneous is minus d by dt of slope of this is slope of this curve. Okay. Similarly, we can apply the same for products graph. In the products, when we plot the concentration change of products with time, that graph should be like this, right? So this is also a time axis. For example, this is the time where you want to know the concentration of product. Just you draw the perpendicular and onto the y axis, draw the perpendicular from x axis to on the curve, and draw a perpendicular from this curve to curve onto the y axis. Okay. So this is the concentration of a product P1. Okay. And if you this is the another time T2. Okay. You want to know the concentration corresponding to this time T2, then you just draw a perpendicular and again draw a perpendicular to this perpendicular onto the y axis, and that corresponds to concentration of P2. Okay. Right. Okay. So average rate or rate average is equal to change in concentration with time taken for the change. Average rate is P2 minus concentration of P2 minus concentration of P1. Concentration change by time taken for that change, that is T2 minus T1. Here the slope or change is positive, that is why it is represented by a positive sign, right? And this is the average rate. And what is the instantaneous rate? If you want to measure the rate of this particular reaction at a particular instant, then you just draw a tangent on this curve, and measure the slope at that particular instant. That gives the instantaneous rate, that is R instantaneous is equal to plus d by g. Slope of this curve gives the instantaneous rate. Okay. And concentration change with time taken for that change gives the average rate. Okay. So these are the two different terms, average rate and instantaneous rate. So usually we go through the instantaneous rate always, right? Okay. And units for rate of reaction. Already I told you that rate of reaction, that is expressed in change in concentration with time, with the change in time. Okay. Concentration always expressed in moles per liter. Okay. Time is expressed in terms of seconds. Then units are moles per liter second inverse, or the units for rate of reaction. Okay. In the next class, I hope you understand this concept. In the next class, we will discuss another concept in the chemical kinetics. Thank you for watching.